Good evening, sir.
Good evening, Ajay. Yeah. Can you see the screen sharing?
Yes, sir.
Okay. So in the last class, we are talking about the lenses in liquid. And as I explained, whenever the convex lens is immersed inside the water, focal length is going to increase by how much? Focal length is going to increase by how much?
So 4 times.
4 times. Since the focal length increases, what happens to the power?
So decreases.
Decreases, no. Because power is inversely proportional to?
Focal length.
Very good. Focal length. Yeah. This is what we have studied in the last class. So now let us move on to the next concept, that is lens formula. Lens formula. Now, you know that in the case of a convex lens, if I considered any lens, either convex lens or a concave lens, so if I say this is a convex lens, this convex lens is having a focal length F. What is this line called?
Principal axis.
Principal axis. On the principal axis, if I place the O, that is object, U represents the object distance. Then whenever this ray of light is incident here, let us say that somewhere the image is going to be formed here. Let us say this final image will be I. What is the final image distance? V. Now, there is a relationship between F, U and V. The relationship between F, U, V is what we called as the lens formula. So lens formula is what? 1 by F is equal to 1 by F is equal to what? 1 by V minus 1 by U. This is the lens formula. 1 by F equals to 1 by V minus 1 by U. Students, please be very careful. You have to use the sign convention while using these formulas. Have you remembered the mirror formula?
Yes, sir.
What is the
Yes, sir.
difference between that mirror formula and the
So
lens
for
formula?
mirror formula, it is minus.
The mirror formula is 1 by f
Sir,
equal
it's
to 1 by
u
v plus 1 by
1 by
u.
u.
Very good,
Sir,
very good.
sir,
So
just
in the mirror
minus
formula, we
plus,
have plus here.
plus, sir.
Here we have plus. Yeah. And how do you define the magnification? As in the mirror, in the lens also it is same. It is size of the image by size of the object, or image distance by object distance. But in the mirror, we are writing minus sign here. Have you remembered?
Yes, sir.
In
Yes,
the
sir.
mirror, we are getting minus v by u. But in the case of a lens, it is just v by u. On simplification from this, we can reduce the another two important concepts. That is in the two different forms. F divided by f plus u, f minus v divided by f. Don't get confused. This is with respect to what? Lens. With respect to lens. So this is the magnification formula for lens. F divided by f plus u. Athwa you can also write f minus v divided by f. Got it?
Yes, sir.
Yeah. Next concept, very important for competitive. Cutting off lens. Cutting off lens. Look at the first diagram. Look at the first diagram. In the first diagram, this is the convex lens. Now we are going to cut the lens vertically. Along the vertical, the lens is going to cut. Now, if you cut vertically, how many lenses is going to be formed?
2 lens.
Yeah,
Yes,
it is
sir.
the combination of two plano convex, right?
Yes, sir.
Yes,
It
sir.
is the combination of two plano convex lens. Now, before cutting the lens, the focal length is f, the power is p. After cutting into the two plano convex lens vertically, each lens will become double the focal length. Each lens will become what? Double the focal length. But the power will reduces to half, p by 2. So if you cut the convex lens vertically, then what is the focal length and the power of the single lens? Focal length becomes double.
Sir, double, sir.
Power of the
2x,
lens becomes p
half,
by
sir.
2.
Half.
P by 2. Similarly, if you cut the lens vertically, in the second diagram, if you cut the lens vertically, you are going to get two convex lens only. Two convex lens you will get like this. Since it remains the same type of convex lens, the focal length and the power will not change. The focal length and the power will remain
Same, sir.
So only the focal length and the power is going to change if you cut the lens vertically. If you cut the lens vertically. Now, why it becomes double the focal length? For that, please remember, there is a logic here. This is one convex lens. What is the focal length? F1. Now I'm going to write one more convex lens. Focal length is F2. This is L1, this is L2. Fine. These two thin lenses are in contact. These two thin lenses are contact. Now I'm going to replace these two lenses by a single lens. I'm going to replace this two single lens by a single lens, which gives the same effect. Let us say that effective focal length is F. L is the equivalent length of L1 and L2. In this condition, we have considered the two individual lenses L1 and L2. What is the focal length of L1 and L2? F1 and F2. These two lenses are in contact. If these two lenses are in contact, if I replace these two lenses by a single lens F, then please remember this F should be equal to 1 by F should be equal to 1 by F1 plus 1 by F2. Effective focal length 1 by F is equal to what? 1 by F1 plus 1 by F2. 1 by F is equal to 1 by F1 plus 1 by F2. One by F equals to 1 by F1 plus 1 by F2. So please remember these two formulas. When two thin lenses are in contact, what is the effective focal length formula? 1 by F
So
is
1 by F1 plus 1 by F2.
Yeah, you can use this concept over here. If I club these two lenses 2F and 2F in contact, if I bring these two lenses in contact 2F and 2F, how to calculate the effective focal length 1 by F? 1 by 2F plus 1 by 2F, no. 1 by 2F plus 1 by 2F is how much? 1 by F. So you will get the effective focal length F. To get the effective focal length F, you have to add up this two. So the 2F and 2F becomes the focal length for the individual lens. It is just a cross verification of a, but please remember these two important concepts. That is cutting of a lens and the two lenses in contact. Yeah. Look at this. This is also very, very important for competitive. That is silvering of a lens. Silvering of a lens.
Lens, sir.
Yeah. What is the meaning of this silvering of a lens? Look at this. If you silver the surface of a lens, it will behave like what? Mirror. If you silver one surface of the lens, then that surface will behave like a mirror.
It's a plain mirror, sir.
Yeah. So the reflection will take place instead of refraction. Okay.
Yes.
Yeah. Now, look at this concept. In this silvering of a lens, 1 by F will be equal to 2 by FL, where FL is the focal length of the lens where the refraction is taking place. 1 by FM. FM represents the focal length of the mirror. What is FM represents?
So focal length of the mirror.
Focal length of a mirror. FL represents the focal length of the lens from where the refraction is taking place. Sir, why we are writing this 2 for refraction? Look at this example. If I consider this is one plane mirror. If I consider this is one spherical surface. If I incident a ray of light here, this is refraction. Here it undergoes reflection. Here also it undergoes reflection. Here, this is reflection here. After reflection, once again here it undergoes refraction, right?
Yes, sir.
So how many refraction you can see in this phenomena?
Sir. 2, sir.
2 refraction. 2 times the refraction is taking place. 2 times the refraction is taking place. 1 time the reflection is taking place. Because of that reason only we are writing 2 here. So what is the formula if one surface of the lens is silvered? 1 by f is always equal to 2 by fl
Sir, 2 by FL
plus 1 by
1 by
fm.
FM.
Got it? Yes or no?
Yes, sir.
Yeah. Come to this first case. Come to the first case. Which surface is silvered? First case. Which surface is silvered? Which surface is silvered? First case.
Sir, the
Convex.
convex surface, sir. That lens
Yeah.
surface, that convex
So
one.
this is plane surface, right?
Yes, sir.
This is convex surface is polished. So I will keep this one plane surface as it is. So this is curved surface is polished. When curved surface is polished, it will behave like a mirror.
Yes, sir.
Yeah. Can you tell me the lens maker's formula for this lens? For lens, can you tell me the lens maker's formula? 1 by
Yes,
f
sir.
equals to refractive index mu minus 1 into 1 by
So 1 by
R1. No,
R1 minus 1 by R2.
no, R2 you don't write. Because what is the radius of curvature of the plane surface? Another surface is plane, no here.
Yes, sir.
So the radius of curvature of the plane surface R2 will be infinity. So it will be 1 by infinity will be 0. So you can just take 1 by R. 1 by F is mu minus 1 into 1 by R. What is F then? What is the focal length of the lens then?
So R by mu minus 1.
R by mu minus 1. So for this case, what is the focal length of the lens? Remember this formula. If convex surface is silver, what is the focal length of the lens?
So R by pi
Mu minus 1.
mu minus 1.
Yeah. The other surface is mirror, right?
Yes, sir.
This is mirror, no?
Yes,
What
sir.
is the focal length for the mirror? For mirror, R equals to 2F alpha.
Yes, sir.
So what is the focal length of the mirror? R by 2.
So R by 2, sir.
So this is the focal length of the mirror. Yeah. If you know FM and FL, can't you calculate capital F by using this formula?
Yes, sir.
If you use this formula to calculate capital F, by substituting FL value and FM value, what you will get? F is equal to
So
R divided
R by
by
2 mu, sir.
2 mu. You got my point?
Yes, sir.
Yeah. Now, I will just keep quiet. You have to answer me or you have to give the explanation for this second case. For second case, which surface is polished?
Sir,
Here curved surface is polished,
Sir,
right? In the first
yes,
diagram.
sir. So in the second case, it's the plane surface that's polished, sir.
Yeah, second surface is polished with a plane. So
Yes,
instead
sir.
of getting a curved mirror, what type of mirror you will get? Instead of
plane
getting a
mirror,
curved
sir. It's a
mirror,
plane
what type
mirror.
of mirror you will get?
So plane mirror.
Yeah, plane mirror you will get. So this will be a plane mirror now. Yeah, this is normal planar convex lens, right?
Yes, sir.
Can you tell me what is the focal length of the planar convex lens? It will be r divided by mu minus 1 only, right? R divided by
Yes, sir. Mu minus 1, sir.
the same method, same method.
Yes, sir.
Now, what is the focal length of this plane mirror? For plane mirror, there will be no focal length. Focal length will be infinity.
Yes, sir.
So what is the focal length of the plane mirror? Infinity. So if you know the focal length of the mirror and the focal length of the lens, can't you calculate f by using this formula? 1 by f equals to 2 divided by fl plus 1 divided by fm. On simplification, you will get this. R divided by 2 times of mu minus 1. R divided by 2 times of
So
mu
mu
minus 1. Any doubt?
No, sir.
Yeah. Come to the third case, which is silvered.
So, sir, in this case, sir, the second surface, sir, of the lens is silvered, sir.
But it is not a plane or convex, right?
Yes, sir. It's a double convex lens, sir.
Yeah, it
Biconvex
is a
lens,
double
sir.
convex lens. In the case of this double convex lens, if one curved surface is polished, can you write the combination? It will just combination of one convex lens and one combination of curved mirror. So what is the focal length of the curved mirror?
Focal length of the curved mirror will be
R by 2.
R by 2, sir.
Yeah. What will be the lens maker's formula this for normal convex lens? 1 by f equals to mu minus 1 into 1 by r1 minus 1 by r2. Since it is a equiconvex lens or a double convex lens, radius of curvature must be same, no?
Yes, sir.
But R2 will be negative. It will go with opposite incident ray. So R2 is negative. R1 is positive. So R2 will be negative. So minus of minus becomes what? Plus. So 1 by f equals to mu minus 1 into 1 by r plus 1 by r. So 1 by f equals to mu minus 1 into 1 by r plus 1 by r will be 2 by r. Taking reciprocal, what will be f value? Taking reciprocal, what will be f value?
So F
R
will
by
be
2
R
into
by
mu
2
minus
into
1, sir.
so mu minus 1, sir.
Yeah, this is the focal length of the lens. Now, by using this focal length of the lens and the focal length of the mirror, can't you calculate capital F? So capital F is found to be what?
So R by 2 into 2 mu minus 1, sir.
2 times of 2 mu minus 1. R divided by 2 into 2 mu minus 1. Just use the formula. Which formula you have to use to find that 1 by F? 2 divided by Fm plus 1 divided by, sorry, this is lens, this is mirror. So 1 by F equals to 2 divided by, what is FL you got? R divided by
So
2
R
times
divided
of mu
by
minus
2.
1 plus
Yes,
what is Fm? R by 2. On simplification of this, you will get that. So this is how you are going to analyze the problem based on the double convex lens when it is silvered. So related to this, if you have any doubt, you can ask. So this is the concept, how the refraction is taking place in spherical surface and in the case of convex lens. You have any doubt?
No, sir.
So shall we start the competitive problems, MCQ questions based on this?
Yes, sir.
Yeah. Yes. You can see the screen sharing.
Yes, sir.
Yeah. Look at the first problem. Look at the first problem. What is given? What is given? Focal length does not depend on aperture fine. Power of the thin convex lens is how much? 5 diopter when it is placed in air. When it is placed in some liquid, it behaves as a concave lens. Be careful, it will behave like a concave
The
lens
concave lens.
of focal length (100 centimeter). What is the refractive index of the liquid? What is the refractive index of the liquid? How to analyze it? See here. There is one convex lens here. Refractive index of glass, let it be Ng. Now it is placed with air medium. In the case of this, you know lens maker's formula. 1 by focal length in air I am talking, which is equal to what's the formula? Ng by Na minus 1 into what? 1 by R1
So 1 by
minus
R1 minus 1 by R2.
1 by R2. Now what they are talking? The same lens is going to be immersed. The same lens is going to be immersed in some liquid, right? This is Ng. Now surrounding medium is not air. Surrounding medium is immersed with some liquid, let it be NL. Can you tell me the formula for the focal length in that liquid now? 1 by FL equals to what? Tell me the formula.
NG
by
by
Ng
NL
by N.
Ng by
Ng
NL
by
minus 1
1
into
into
1
what?
by R1
so
minus
1 by
1 by
R1
R2.
minus 1 by R2.
Yeah. But one more important concept they have given. One more important concept is given. When it is immersed in the liquid, it will behave like what type of lens?
Concave lens.
So inside this liquid, actually, it is not a convex. It is behaves like what type of lens? Concave lens. It behaves like a concave lens. So if I call this equation as 1 and if I call this equation as 2, can I divide equation 1 by 2? If I divide equation 1 by 2, can you tell me what will happen? 1 by FA, whole thing divided by 1 divided by FL will be equal to Ng by Na minus 1 divided by Ng by NL minus 1. I'm not going to write 1 by R1 minus 1 by R2 because in the equation 1 and 2 that will be the same. If I divide those two equations, it is going to get cancelled out, isn't it? Yes or
Yes,
no?
sir. Yes,
Yeah.
sir.
Now this FL goes to numerator, right?
Yes, sir.
So FL divided by FA is equal to, you know that numerator is just Ng minus 1 because refractive index of air is how much? 1. Whole thing divided by Ng by Nw minus 1. Can you tell me the data? What is the power of the lens in air? 5D. What is focal length in air then?
So 1 by 5.
That is 0.2.
Yes, sir.
So this is focal length in air. What is focal length when it is immersed in liquid?
100
So 100
centimeters.
centimeters.
100 centimeter means how many meters?
So 1 meter.
Instead of writing 1 meter, shall I write minus 1 meter?
Yes, sir. Because it's
Why should I write minus?
so concave lens, sir.
Because in the liquid it behaves like a concave. So focal length will be minus 1. What is refractive index of glass? Ng? .5, no.
Yes, sir.
Yeah. What about NL? You have to find. You have to find NL. Yeah. So I'll keep focal length of the lens as minus 1. Focal length of air is 0.2. Refractive index of glass is 1.5 minus 1. Whole thing divided by Ng by Nw. That is Nw means liquid I'm talking. That is 1.5 divided by NL minus 1. Can you simplify this and tell me the value of NL? Can you simplify this and you can tell me the value of NL?
Yes, sir.
I will do that here. Minus, what is 1 divided by 0.2? Minus 5. 0.5 by 1.5 by NL minus 1. Now at least you do the cross multiply and tell me the value of NL. Why you are not getting?
Sir, no, sir. Could you do it, sir?
Options are not there.
Sir. Yes, sir, but I'm not getting, sir. Could you do it, sir?
Okay, let me solve for you. Now, can I take this 1.5 by NL minus 1 to the LHS?
Yes, sir.
So it will become 1.5 by NL minus 1. This is, if I shift minus 5 to the denominator of RHS, it will become minus 0.5 by 5, that is 0.1, no?
Yes, sir.
Yeah. If I shift minus 1 to that side, it becomes what? One minus 0.1
Yes, sir.
by nothing, 1. So 1.5 by NL equals to 0.9, right?
Yes, sir.
What is NL from this? Cross multiply, Ajay.
Sir, NL will be 1.5 divided by 0.9, sir.
Yeah, 1.5 divided by 0.9 is 15 by 9, no?
Yes, sir. Yes, sir.
What is 15 by 9?
Sir, 15 by 9 will be 5 by 3, sir.
So which is the right option?
Option A, sir. Yes, sir, I got it, sir. I inverted it, sir. I got 3 by 5, sir. Yes, sir. Yes, got it, sir.
What about Varsha?
Yes, sir.
You got 5 by 3.
No, sir, I was getting another answer.
Yeah, you just check the cross calculation part where you have done wrong. Yeah. Look at this. What type of lens they have given initially? What type of lens is given?
Double convex lens, sir.
What is the refractive index of that glass?
1.5.
What is the focal length of that glass?
So
10 centimeters, sir.
Yeah. Now, when it is immersed in water of refractive index 3, they are using some liquid. The liquid refractive index is 3. Now, they are asking you to find the lens will behave like what? The lens is going to behave like what in that liquid medium? Yeah. Now, can we tell the direct formulas? 1 by FA is always equal to Ng minus 1, right? 1 by FL is equal to what? Ng by minus 1, right?
Yes, sir.
I'm not going to write 1 by R1 minus 1 by R2. You know, if I divide these two equations, it is going to get.
So
Why I am not writing 1 by R1 minus 1 by R2? You tell me.
so 1 by
Because
R1.
they'll get cut when they are divided.
Very good. It is going to get cancelled out when you divide this two. So focal length of lens goes to numerator by focal length in A, which is equal to Ng minus 1 divided by Ng by NL minus 1.
Yes.
If possible, try to remember this formula directly to talk about when the lens is immersed in some liquid medium. FL by FA is always equal to Ng minus 1 divided by Ng by NL minus 1. Now you do the correct calculation. You do the correct calculation for me. What is focal length in lens? FL. What is focal length in air they have given? 10. Ng value they have given as 1.5 minus 1 by 1.5. Liquid value is 3 minus 1. So FL by 10. What is 1.5 minus 1?
0.5.
Correct, no? What about this? 1.5 by 3 is 1 by 2. 1 by 2 minus 1 is minus 0.5, right? 1.5 by 3 is 1 by 2. 1 by 2 minus 1 is 0.5, no?
Yes, sir.
So FL by 10 equals to minus 1.
Yes, sir. So
FL
FL
by
will
10
be equal
equals to
to
minus 1.
FL will be
On
equal
cross
to minus 10.
multiplication, FL will be minus 10 centimeter, isn't it?
Yes, sir.
What is the meaning of this negative sign, my dear?
So it's a concave lens, sir, diverging.
Negative lens, negative focal length means it is a diverging lens, as you
Yes,
told.
sir.
Yes. Diverging lens. Diverging lens means what type of lens?
Concave lens.
Very good.
Concave, sir.
So, when you immerse the lens inside that liquid, it is going to behave like a diverging lens of what focal length?
10 centimeters, sir.
So, which is the right option?
Option A.
Yeah.
So option A.
And one more thing you remember, if you put the lens in the greater refractive index medium, lens has to change. So convex lens becomes what? Concave lens. So easily you can delete the option C and option D. Option C and option D can be deleted easily. So you can
Yes,
do the calculation, either it is for A or B. Understood?
yes, sir.
Yeah. Yes, look at this third problem.
ಎತ್ಕೊಂಡು ಮಾಡಿದ್ರೆ ಚೆನ್ನಾಗಿ ಮಾಡ್ತೀಯಂತೆ ಅವಾಗಲೇ ನಿಂಗೆ ಹೇಳ್ತೀನಿ ಇಡಬೇಕು ಈ ಗ್ಯಾರೇಜ್ ಅಂಗಡಿ ಬಂದು ನೋಡೋದಕ್ಕೆ ಇಡ್ತೀಯಲ್ಲ ಹಂಗೆ
Look at the third problem. Figure is going to shows below a light converging at the point P. Sorry. So the figure shows here a beam of light converging at a point. If it is a converging, maybe what type of lens it is?
So convex.
Convex lens, sir.
Yeah, convex lens. Now, there is one more lens, that is concave lens of what focal length? 16 centimeter is introduced in
16
the path.
centimeters.
Is introduced in the path of the beam at a place O. Somewhere here they have placed concave lens. That is by the help of this dotted line they have shown, which is at a distance x from the lens. From the lens, it is at what distance? X.
So X, sir.
What type of the value of x will be? What will be the value of x will be? Now, if I introduce one lens at the dotted line, if I introduce the dotted line, let us say here I am going to use one lens. If I introduce this lens, it is going to converge us to some particular point. Let us say that particular point will be some P dash, which is at distance, at a distance x
Sir,
from the
X,
lens.
sir. X,
If I say this is the lens, it is going to converge at a distance x. At a distance x. Now let me write the another formula for you. If I not use the lens, the rays are going to converge to the point P. This is the point P. This is the dotted line. What is the distance they have given? 12 centimeter.
So 12 centimeters.
Now, if I put a lens, it is going to converge to one particular point. This is P dash, which is at a distance x from the lens. Correct, no?
Yes, sir.
Yeah. So from this figure, can you tell me what is the object distance for this lens? P will access the object. So what is the object distance? (12 centimeter). After introducing this lens, where the image is going to be formed?
Sir,
At X.
X,
At
sir.
X. What is the focal length they have given?
Sir,
16 centimeters, sir.
Yeah, 16 centimeter. Now, what is your lens formula?
1 by F equals to 1 by V minus 1 by U.
Yeah, 1 by. Focal length is 16. Since it is a convex, it should be a positive value. 1 by V minus 1 by object distance is minus 12, no? Or plus 12? It is plus 12 only. Why plus 12? Incident ray is acting in this direction. Object distance is also measured in the same direction, right? This is incident ray. This is object distance. So incident ray and the object distance are in the same direction. So U should be positive. Can you simplify this for V?
So 1 by V will be,
You calculate V. No, not 1 by V. You calculate V only.
yes, sir.
Take the reciprocal and you simplify and you find the value of V. How much you got?
So is it 48 centimeters, sir?
It is 48.
Centimeter.
48 by 7, sir.
So it's 48 by 7. So what?
Option is not there. So
Yeah.
check whether where we have done wrong. Yes, look at here. I told it is what type of lens? I have marked somewhere here. What type of lens?
So concave.
Concave lens.
Yeah, forgot that. So for concave lens, what is the focal length? Focal length will be negative, right?
Sir.
So it should be minus 16. So 1 by V equals to 1 by 12 minus 1 by 16, right? If I shift this 1 by 12 to the LHS, it becomes plus 1 by 12. So 1 by V equals to, what about the LCM between 12 and 16?
48, sir.
Yeah, 48. So 12 fours are 48. 1 by 16, 16 threes are 48. So 1 by V equals to 4 minus 3 by 48. So 1 by V equals to 1 by 48. So V will be equal to what?
48 centimeter.
48 centimeter. So the image actually X is going to be formed at beyond this P, because it is a concave lens, right? So it forms at 48 centimeter beyond that. So which is the right option?
So option D, 48.
Yeah, option D. Look at this next problem. What type of lens it is? First one?
Convex lens.
So convex lens is positive. So it is plus 40 centimeter. It is in contact with concave lens. Concave lens means F2. It is minus 25 centimeter, right? Because it is a concave.
Yes, sir.
They are asking you to find the power of the combination, isn't it?
Yes, sir.
The power of the combination they are expecting. Power of the combination. You know that power is the reciprocal of focal length. Power is the reciprocal of focal length. F stands for effective focal length of the combination. Here, these two lenses, F1 and F2, they are in contact, right?
Yes, sir.
When they are in contact, effective focal length 1 by F is equal to what? 1 by F1 plus 1 by F2. So 1 by F equals to, what is 1 by F1? 1 by 40 plus 1 by minus 25. So 1 by F equals to 1 by 40 minus 1 by 25. You simplify this. 1 by F equals to, between 40 and 25, LCM will be 200, right?
5 minus 8 by 200, sir.
How much you got? This is 8, ala? 8 minus?
5
Sir,
minus
8.
8, sir.
So 5 minus 8 will come, sir.
Five
So,
minus 8.
yes, sir. So
So 1
200
by F equals to
So
minus
minus
3
3 by
divided by
200.
200. So what will be F? Minus 200 by 3. It is in centimeter, right? Because
Yes,
F1 and F2 are in centimeter. So this F is also in centimeter. Minus
Yes, sir.
200 by 3 centimeter means it is minus 2 by 3 meter, right?
Yes, sir.
So what will be P then? P is
Minus
equal to 1 by F.
1.5 diopter.
So 1 by F means it is minus 3 by 2. No, take the reciprocal, ulta. What is 3 by 2?
1.5, sir.
So what is the unit of power?
Diopter.
Capture.
Diopter.
So it is 1.5 D. Can you
Yes,
tell
sir.
me the meaning of this minus sign here? Can you tell me the meaning of that minus sign?
So it's
So the lens will be a concave lens.
concave lens, sir.
Yeah.
So concave,
So-
diverging lens, sir.
Yeah. So I'm going to club the two lenses here. One is convex. The another one is concave. Actually, these two lenses are in contact. These two are in contact. The combination of this is going to be is like what?
Concave lens.
Yeah. This combination is going to be is like a concave lens. That is the meaning of that. So minus 1.5 diopter is the effective power of that combination. Yes. Any doubts related to this? You have any doubt related to this?
No, sir.
Yeah. So next problem is little bit more calculation is involved here. I will take up this fifth problem in the next session. So still there are around 8 problems, still 8 to 9 problems are there, so that I can complete this in the tomorrow session. So after this, we'll go with the optical instruments. That is the last part of the ray optics. Okay. After completing this chapter, we will take some few 15 questions of combining all the concepts. So far, we are doing the problems based on concept wise. After completing the entire concepts of ray optics, we will take some 15 to 20 questions and we will discuss that. But all those questions are shuffled. It is not a concept by concept. All the problems will be a shuffled one. We will solve those type of mixed questions at the end of the chapter. Okay. Fine. I will stop at this stage, Appa. We'll continue in the tomorrow's class. Thank you.
Thank you.